Hello guys, this is Amel Peralta and I'm glad to be back. Remember that last time I showed you the theory about how to actually implement a two-dimensional array, but now it's time to add two-dimensional array because now that you have the basic idea, now we're going to apply that idea. We're going to write the two-dimensional array so that you understand how it is done. So I'm going to open Mars, and in this program that I'm gonna write, I'm gonna write an array, a two-dimensional array, and we're gonna add all the elements in the diagonal. So it's gonna be a program that is gonna allow you to actually display the sum of all the elements in the diagonal. So first I'm gonna click on File, then New. I'm gonna save this to my desktop. I'm gonna call this MD array for multidimensional array. So as usual, I'm gonna start with the data section, and here I'm gonna have my multidimensional array. I'm gonna call it MD array. The type of elements is gonna be integer, so I'm gonna say that word, and it's gonna have 2, 5 in the first row, that word 3, 7 on the second row. So I'm gonna say that I have a multidimensional array. The name of the array is MD array. The type is integer. The first row is 2, 5. The second row is 3, 7. So this is a square matrix. And by square matrix, I mean that it has the same number of rows and the same number of columns. So it has 2 rows, 1 and 2, and it has 2 columns, column 1, column 2. And why am I doing it this way? I'm doing it this way because I want to simplify my code. That way, it's going to be easier for you to understand. And once you understand this way, you can actually change it to a different way. You can actually have a rectangular matrix if you don't want to have a square matrix. So now I'm gonna have another variable in random access memory, and this is gonna be the size. So size is gonna be an integer. So because I have 2 columns and 2 rows, the size is gonna be 2. And this is one simplification because the number of columns and the number of rows is the same. I only need to have one variable for the size. It's a 2 by 2 matrix. And now I'm gonna define a constant. Before, I never showed you how to define a constant. So this is the way we do it. We say dot EQV, that's for constant. So it says substitute second operand for first. The first operand is symbol, second operand is expression. It's like pound define if you know C or C++. So that EQV, the name of my constant is gonna be data size. So because I'm dealing with integers, the data size is 4. If I was dealing with doubles, the data size would be 8. But in this case, it's 4. This way, my program is going to be easier to maintain, because if I need to change the program from integer to double, I only have to change this. If I want to do it later, I don't have to go through my code and change it and change all the instances. I only have to change this value here. Okay, so this is all the data that I need. Now I'm gonna go to the text section, and this is for the code. So now I'm gonna have my main function. In my main function, I'm gonna have, the first thing I'm gonna do is that I want to have the base address of my multidimensional array. So I'm gonna say load address $A0, MD array. So now register A0 has the base address of my multidimensional array. But I also want to have the size, which is 2. in a register. So I'm going to say load word $A1, comma size. So now A0 has the base address and A1 has the size. So I'm gonna call a function. I haven't written this function yet, but I will write it later. So the function is called sum diagonal, because this function is gonna add up all the elements in the diagonal. In this case, I have 2 and 7. This is the diagonal. So 2 plus 7 is 9. So I'm going to say jump and link sum diagonal. And the arguments, notice that these are the arguments. It takes 2 arguments, this function. It takes the base address of the multidimensional array, and this is in A0, and the size, which is in A1. Remember that the A registers are used for parameters, for arguments. And once I call the function is going to return the sum of the diagonal elements in register V0. So I'm going to move to register A0 the value in register V0. So the sum is going to be stored in V0 when I return from this function. This is going to have 2 plus 7, which is 9. This is going to have 9, and I want to put it in A0. So now A0 has 9. But why am I putting that in A0? Well, because I want to display the value to the screen. So now I can say load immediate $sign V0, comma 1, and this is to display an integer to the screen. What integer I want to display? The integer in A0, because by convention we pass the argument to A0. And then I have to say syscall. And with that, the system is going to display the integer in A0, in the argument A0, to the screen, which is going to be the sum. 2 plus 7 is 9. Okay. And then I'm going to end the program in main. So I'm going to say load immediate $sign V0, 10, syscall. Okay, so this is the main procedure. This is my data. And now I have to implement the most important part of this tutorial, which is the function sum diagonal. Remember that sum diagonal takes these 2 parameters, A0, the base address, and A1, the size. So for this tutorial, we're going to use the row major representation. This is the row major representation. And remember, in the last tutorial, I said that row major is the following. We go row by row and we add the rows in contiguous memory. So row 1 first, then row 2, and then row 3. So we have to use this formula. So we're going to implement this formula to get all the elements in the diagonal. So I'm going to say sum diagonal. That's the name of the function. So first I'm going to say load immediate $sign V0, 0, because I'm going to use V0 to return the sum. Remember that V0 has the sum. V0 has the sum. Okay, and I'm gonna say load immediate $sign T0, 0, because I'm gonna use T0 as the index. Okay, so now I'm gonna say sum loop. This label is going to allow me to have a loop. It's going to add all the elements in the diagonal. So first of all, I'm going to say multiply $sign T1, $sign T0, $sign A1. So what I'm doing here is the following. I'm multiplying T0 by A1, and the value is going to be stored in T1. So I'm saying T1 gets the value of row index times the number of columns. So notice that I'm applying the formula from here, from row major representation. So row index times the number of columns. So T0 is the index. Initially 0. The first iteration is going to be 0. Then it's going to be 1. So row index, which is T0, multiplied by the number of columns. What is the number of columns? Well, it's right here. Remember that the number of columns is the size, which is 2. We have 2 columns. Now we need to continue implementing this formula. So now that I have row index times column size, I need to add the column index. So I'm going to say add $T1, $T1, $T0. So what I'm doing is that to all this, I'm adding the column index. And realize that the row index is the same as the column index. Why? Because I'm working only with the diagonal. So if I go back here, I show you this, we're going to be adding the diagonal elements. So the row index is 0, the column index is 0, the row index is 1, the column index is 1, and so on. So it's a simplification because we're only working with the diagonal. The row index is going to be the same as the column index, or it's going to be the same as the size in my program here. So now I have that T1 is equal to the row index times the number of columns plus the column index. So I have done this part of the formula. So now I have to multiply all these by the data size. So I'm going to say multiply, store the value in T1, $T1, and I'm going to use my constant, which is the data size. So now T1 has the value row index times column size plus column index, and all that multiply by the data size. Because the data size is 4, because I'm working with integers here. So I have all these already, this formula all the way to here. Now I need to add the base address. So I'm going to say add $T1, $T1, $A0. So what I'm doing here is that I'm adding the base address. So remember that in the data section, we have the base address is MD array. So in main, we are putting the base address in register A0. So load address A0, MD array. So we are adding the base address. And so T1 has the address now. After all this calculation has been done, now T1 has the location in random access memory for the element that I'm looking for. So the first iteration, T0 is 0. So the first iteration, after all this calculation has been done, T1 has the address of the first element, which in this case is going to be this element 0, 0. So all these, the location is here. So now I can get that value. I'm going to say load word in register $T2 parentheses $T1. So I'm getting the element in the first position, and I'm putting that element in register T2. So this element, I'm getting that element from random access memory, and I'm putting that element in register T2. And now I want to add it to register to the sum. So add $V0, $V0, comma $T2. So this is equivalent to saying that sum gets the value of sum plus MD array sub I sub I, because the row index is the same as the column index. So each iteration, I'm going to perform this calculation to get the corresponding element in the diagonal. Then I'm going to get the element from random access memory, and then I'm gonna this element from random access memory, I'm going to add to the sum, and I'm going to do that every iteration in the loop. So now I need to increment the loop counter or the loop index. So I'm going to say add immediate $T0, $T0, 1. And this is equivalent to saying I gets a value of I plus 1. Because remember that T0 is the index. So I'm incrementing the index every iteration. And then I'm going to write my loop condition. I'm going to say branch if less than $T0, $A1, sum loop. So I'm saying that if I is less than the size, loop again. So it's gonna, if the index is less than the size, it's gonna go back to the loop. So let me write a comment here to make it clearer. So if I is less than the size, then loop again. And this loop right here is gonna go through the array, through the multidimensional array, and it's gonna add up all the elements in the diagonal. So in this case, it's gonna start with 2, and then it's gonna go to 7, and it's gonna say 2 plus 7 is 9, and then 9 is gonna be stored in V0. So we just need to return from the function. So we say jump register $RA. And that's it. Now I'm gonna test it. I'm gonna save, I'm gonna assemble. So I have a little error. Let me see what the error is. Okay, it's right here, line 25. So multiply $T1, $T0, $A1. Let me fix it up a little bit. Save. So T1, T0, A1. Let me try this. Let me check. MUL. Oh yeah. Actually, I made a mistake here. I'm using MULT as MUL. All right. Save. Clear. Wrong. Assemble. And as you can see, 9 is the result. 2 plus 7 is 9, and it's right here. But now, what if I want to make this a 3 by 3 array? Well, it's pretty easy. I'm gonna add more elements. I'm gonna say 7, no, I'm gonna say 8, I'm gonna say 10, one more row, I'm gonna add 1, 4, and I'm gonna say 11. And now this is no longer a 2 by 2 multidimensional array. This is a 3 by 3 multidimensional array. And the size is still 4 because we're working with integers. But now, if we execute this program, it's gonna go through the diagonal. It's gonna say 2 plus 7 is 9, and 9 plus 11 is 20. So we should see 20. So save, run, assemble, and execute. Voila, 20 is right there. So as you can see, this is working perfectly. We have a multidimensional array, and we have a constant for the size of the element. And this function is gonna add up all the elements in the diagonal. And notice that we only need one loop because we are only going through the diagonal elements. So thank you for watching. Please like this video. Please subscribe to my channel. And I hope to see you soon. See you next time.